welcome back to our second parent information session. Thank you for continuing the journey with me to understand the brain's role in children's learning. I'm Dr. Small, the Executive Director of A Stronger Foundation. The following content intends to educate parents on productive educational practices that enhance learning achievement and foster readiness for the real world. The information about the brain's general role in education is public knowledge and does not represent medical advice. I am not a medical doctor. Now, from the last video, remember the role of the four structures of the limbic system. The thalamus is the doorway for all sensory input from our environment, except for smell. A keynote was that logical and illogical input competes for entrance at the exact location. Next, we discussed the hypothalamus as the second stop of sensory input once it is through the thalamus. The hypothalamus checks the input for any possible threats it may pose to the body's normal balance. Its role is to keep all the body's systems at equilibrium or homeostasis. The input then passes through the hippocampus where consolidation occurs to properly distribute the signals. Finally, I discussed the amygdala, which introduces the emotional elements of the limbic system with a reflex to fight, flight, freeze, or engage. In conclusion, I asked you to ponder a question that will be developed in this video. What does the hypothalamus consider a threat? Remember, in the first video, we learned the function of the frontal lobe as the executive control center for rational thinking and problem solving. We also learned that signals from logic related structures as well as the emotional control center compete for entrance through the same area of the brain. Now, here's something crucial to our conversation. The frontal lobe, where rational and higher order thinking occurs, matures slower than the other parts of the brain. Therefore, this means the limbic system, the structure that modulates emotions, matures faster. By age 10 to 13, the child's limbic system is fully matured, while the frontal lobe continues to mature into early adulthood. What does this mean? The child is more irrational than logical, emotionally stronger, logically weaker. Therefore, the child's frontal lobe, which essentially would employ logical responses, cannot control young people's bombarded emotional challenges. This is one crucial reason young adults are prone to yielding to their emotions and engaging in risky behaviors. Therefore, a child will risk their education because they can't understand its future implications. Now you can understand that kids don't necessarily want to ruin their future. They are not sufficiently developed to make the sensible choices presented through their amygdala. For this reason, I believe it's unethical to allow children to dictate their education. They're simply not equipped to do that. Children in K through 12 still are not fully able to reason correctly. Unfortunately, the adults in their lives are incredibly intimidated and neglect to be substantial where the child is weak. As an adult with a fully matured frontal lobe can make rational, logical, sensible, and common sense decisions, many adults succumb to a child's emotional responses. Why? Because with a fully developed limbic system, a child's emotional reactions outweighs an adult's logical responses. What does all this mean? Adults are afraid of kids. And this ridiculous truth is ruining our children's future. Risky behaviors include compromising their education, blowing off homework, not completing assignments, or even skipping school. They cannot calculate the consequences and long term implications, such as how it will impact their lives economically and whether they thrive or barely survive. Here is how it consolidates to unfold in a child's educational episodes. First, consider this. The primary two structures, the cerebrum and the cerebellum, which aid in retention and long term memory, reside in the emotional segment of the brain. Therefore, the child's brain engages with the approaching sensory signals during instruction in a classroom setting. The goal is for the brain to prioritize the instructional content to enter the thalamus and be perceived as non threatening input. Again, that is the goal. Now, upon the success of this goal, the academic signal would then proceed to the hypothalamus to be processed, consolidated, and assigned to the correct brain area based on assimilation or accommodation. From there, the knowledge would have successfully transitioned from working memory to short and eventually long-term storage. That is the ideal learning experience. If this occurred, every child would reach their highest academic potential. Furthermore, there would be minor or no learning gaps. In this scenario, only signals from the cerebrum and cerebellum were present. However, various signals are constantly ushered to the brain as we engage in our environment. In a normal situation, the hypothalamus must decide which signal to admit first, since, as we discussed in our analogy, only one can enter at a time. The hypothalamus will determine the signal to receive priority based on its perception of potential threat to the body's homeostasis. If the lesson adds single-digit numbers, regardless of the grade, the brain will embrace this signal as non-threatening and permit it to proceed for further processing because it's easy. In this case, the signal was perceived as non-threatening because the child had prior experience and an existing schema that allowed for assimilation to occur. As a refresher, assimilation means that there is already a similar content in the brain to which the hypothalamus can affix the new knowledge. If new knowledge were presented in the instruction, however, the arriving signal would have been rejected during the hypothalamus screening to prevent any distress to the child. Distress would throw the child's system out of balance and disturb homeostasis. From here, the child's amygdala would activate and oversensitize the situation to mid to high panic attack. It would trigger an immediate protective response to either fight, flight, freeze, or disengage. This is an explanation of some of the classroom responses and behaviors. Some of the child's common responses include disrupting the lesson, showing disrespect, refusing to engage, or shutting down altogether. The higher the grade of the child and the level of learning gaps, the more intense the responses. So, a first grader with fewer learning gaps, fewer memories from the past, failing experiences, and more malleability due to the development stage may exhibit a milder response than a fifth grade student who has embraced the hierarchical order. Similarly, a first grader can be redirected more easily than a fifth grade student. So now you should understand why a child would more likely exhibit an emotional response than attempt to focus on understanding the new knowledge presented in a classroom. Based on their brain development, the emotional response is the most productive and sensible response. They are not aiming to be disrespectful. They are in self-preservation mode. The lesson is perceived as a threat, and the brain triggers an automatic combative defense to maintain safety. The poor learning aptitude habits are hardened when the child gets to middle school. The child has developed a personality that protects their weak education elements with a dome. This is a highly sensitive area. It's where they are bruised. They build a dome around it and develop a hard, protective external surface with an expressed, competent facade. So, when multiple signals approach the hypothalamus, one from a classroom environment, including new lesson content, and another from an emotional memory of a child's insecurity with the new knowledge being presented, the hypothalamus would prioritize the fear based signal. In response to the fear, the amygdala would cause a response that aims to eliminate the threat and allow the hypothalamus to regain systemic order. The longer the gaps are permitted to develop, the more failing episodes the child experiences and the more painful learning memories become associated with learning and restrict educational efforts. The sad truth for the learners in the dome is that they fully understand their shortcomings and are afraid. They realize there is future trouble because they know education will determine their livelihood, but they don't see a way out. Instead, they put on a show. Here's how students respond to their educational inferiorities. They yield to utopia to provide novelty to their brains and aspire to a false reality. We see a lot of utopia with middle schoolers, often laughing aloud in cliques to save face and create a facade of the perfect reality. This is their protective mode. So, can we really blame them for trying to protect themselves from the natural human response to danger? Let me mention one more consideration. The brain is described as novelty seeking, which means it constantly craves new and quick stimulation. This is the same component that leads to binge scrolling digital devices. Our brain lives for comfortable stimulation that requires no work, no effort. Before I end this video, I want to revisit the key question. Do you know the answer to what the brain perceives as a threat? It's learning. New knowledge instruction presented to a child lacking sufficient foundation presents a threat and triggers a subconscious response almost like a car coming right at you. Learning is perceived as a threat because it requires work and effort. Learning forces the brain to focus on areas of low interest for an extended period. And therefore, kids can quickly develop resentment towards learning activities. One disclaimer is that not all learning is considered work. Learning is an area of interest Learning in an area of interest is not perceived as learning. If a child loves animals, they may respond surprisingly well to classroom lessons dealing with animals. However, a general classroom learning poses a threat and will never beat out a signal with preferential priority from the novel seeking brain. This idea explains why children embrace the learning of complex video game challenges because it provides constant changing stimulation, including hand eye engagement. Digital learning was implemented based on this concept, but the brain cannot be fooled. Now, I present this information as the source of the education problems we are experiencing. The information in this video presents the root sources of the underlying education problems that go beyond poor schools, bad kids, or teachers, or insufficient curriculum, and it goes to the greater scientific based contributors. Now you understand my perception of how the brain's role in learning contributes to the root problems in education. To summarize this content, my claim is that a weak student will never prioritize learning over non academic signals based on the following. Learning is considered a threat based on the scientific descriptions of the limbic system features. Many programs dwell exclusively on the problems. However, as you will see in the following few videos, I will share a highly potent possible solution to the academic restoration of our students. More details about the solution will be presented in the following video. This video was essential to develop a foundation to follow the upcoming sessions. I appreciate your interest. I hope to see you in the forthcoming sessions. Please like, subscribe, follow, and share this YouTube channel. See you in the next video.